Welcome back to the second section or second part of this section. We're going to continue with our conversation about transformations to make sure that we're really good at these. So what I'd like you to do is first and foremost review from last video. So let's look at this. Well, the first thing I'm going to do is I'm going to notice that I do have a stretch, not only a stretch, but also an x-axis reflection. So I have an x-axis reflection and a stretch of 3. So remember that if this is x squared, that is what makes this column here. Okay? So I'm going to multiply each of these by -3. All right, so I have -2, -12, and yes, I realize that is down below here, right there. Then -1, -3, 0, 0, 1, -3, 2, -12. So just like that. Then, of course, we have to take into account our shifting. So that is shifting it to the right 2 and up 6. So remember now, after I graph based on the stretch, now I'm going to start shifting it around. So over 2, up 6. 1, 2, 3, 4, 5, 6. Over 2, up 6. 2, 3, 4, 5, 6. Over 2, up 6. 2, 3, 4, 5, 6. Over 2, up 6. Over 2, up 6. And there is my parabola in blue. So there's the graph. Now let's recall all that key vocabulary. So first of all, the vertex. So my vertex, well, I shifted 2 to the right and up 6. So my vertex is going to be sitting at 2, 6. Then, of course, the axis of symmetry. Axis of symmetry is at the x value. It's that line that cuts it in half that goes through the x value of my vertex. Then the min or max. Well, here it is the top of the function, so it is actually the maximum value that the function will take. Okay, the vertex is the highest point, the maximum. And the maximum value is always the y value from the vertex. That's as high as a function is going to be able to get. Domain. So again, we really like domain because you get to use all real numbers. It is always all real numbers. You can use any x to plug in. The range, however, the range is what is restricted because we're starting here. We're starting up at that 6. Then I notice all my values are underneath it. It's going downward. So all my y's are going to be less than or equal to that 6. So remember, that's another spot where you start at the y value of the axis of symmetry, and you notice it's going downward, so your range is going to be y is less than or equal to that 6. All right, so again, that's just a little bit of review before we dive in what we really want to talk about today. And what I want to talk about today is the idea that you can identify those pieces without having to graph it. Okay, you can answer all of that vocabulary without graphing this parabola. All right, so here are the steps on how to do this without graphing. Okay, identifying that vocabulary, because there will be a section on the test where I don't ask you to graph it. I just ask you, hey, what's this vocab? And I think that you can learn how to do it without graphing. So the first step, identify the transformations. So the transformations, well, that is going to be a stretch of 4 left 1, and down 3. All right, so if it's being shifted to the left 1 and down 3, here is your vertex. Boom, you already have it. So the vertex is really easy because literally all you have to do is follow the transformation, follow the shifting, and it gives you the vertex already. Then, also really easy, is the axis of symmetry. Because axis of symmetry, remember, you always just take the x value of the vertex. So those two really, I hope, are super easy for you. Just me kind of handing you points on the test. Now this one starts getting a little bit trickier, okay? So now we have to picture what it looks like, all right? Up or down. Well, this number out here is positive, so there's no reflection happening. So the basic shape of a parabola is just looking like that. So I'm going to sketch that on my paper that I know I have a parabola that's opening upward. That's really all you need, okay? That's really, really all that you need. And then if you want, you can label the vertex here is -1, negative. Sorry. So now that I have that little picture sketch, that's going to help me with this next piece. So is it a minimum or a maximum? Well, I'm seeing it's at the bottom of my graph. So that is a minimum. Okay, it's a minimum because it's at the bottom. And that's why I sketch it. It makes it easier to see that. And then, of course, the minimum value is the y value. So it's a minimum, and the value is -3. You always have to give both. Give that it is a minimum, and give what that minimum value is. Domain, again, we love domain. All real numbers. Okay, always all real numbers. And then when we're talking about range, okay, range, so here, think about that vertex. Now you're starting at that -3, that y value of the vertex, and where's the graph going? Well, it's going upward. So all my y values are going to be greater than or equal to that -3. All right? And then that's it. That's all the vocab I need you to know, all the vocab I need you to be able to do right there. All right, so now, of course, let's get some more practice on it. Just saying it once isn't going to be quite enough. Let's do this a couple times just to make sure you're really, really getting the feel for it. So let's start by identifying our transformations. So our transformations, well, there's two of them right there. That's an x-axis reflection because of the negative, and a stretch of 2. That is being shifted right 3, up 7. So that's what I need for my transformations. Now, based on those transformations, it went to the right 3 and up 7. So there's my vertex. Boom. Now let's draw a little sketch. Now there was an x-axis reflection. There's that negative out front. So what that means is it's going to be facing downward like this. So again, I'm just going to sketch that really rough picture. And again, here is that. Now, there's actually something I just realized that I forgot on here. I forgot the axis of symmetry. Remember, axis of symmetry, all you do, take the x-axis, or the x value, from the vertex. Okay, so we take that, the min or max. I notice it's the top of the function, so it's going to be a maximum, and then you use the y value of the vertex. So the axis of symmetry uses the x value of the vertex, the min or max uses the y value of the vertex. Domain, we all love domain. Domain is going to be all real numbers. And then the range. The range, once again, you're starting at the vertex, so you're starting at the 7. And I notice everything is going downward from it. So all those y values are going to be less than or equal to that 7. All right, and the other one. So here I just have a negative out front. So if you just have the negative out front, that's going to be an x-axis reflection. And then that is shifting it left 4, up 5. And I use those transformations. So left 4, sending it towards the negative, and up 5 sends it up, okay, positive. And again, I forgot axis of symmetry. Axis of symmetry just uses the x value of the vertex. Is that vertical line that cuts it in half. Now I'm going to draw a little picture, okay? So I have that negative, so it's going to be facing downward with the vertex sitting on top. So what that means is, again, this is going to be a maximum value, okay? It's the top, it's the max. And what is that value? Well, it's the y value from the vertex. Domain, as always, we all love the domain because it's all real numbers. And then the range. The range, we'll go back and we look at this again. So we're starting at that 5. And I see everything going down from it. So my range, all my y values are going to be less than or equal to that 5. They're going downward. And there's the end of my problem. All right, so we're going to go over one more little kind of extension topic, a fun little topic for you. So you can actually write quadratic functions in vertex form. And let me show you how. So this picture shows the jump of a dolphin. What quadratic function models the path of the dolphin's jump? The dolphin had a height of 7 feet after 3 seconds. All right, so it's vertex. The highest point that I got to was right here at 3.7. So I'm going to model that, okay? So my function, y equals, I don't know if there's a stretch or not. So because I don't know it, I'm just going to label that with an A. Okay, just saying I don't know what that A value is. But I know it got shifted to the right 3 and up 7. So just based on the vertex, I can say that much, okay? I just don't know what the stretch is. Well, there's a cool way that I can actually find what that stretch is. And the cool way that I can do that is the fact that I know another point. Okay, I know the point 12, 0. So after 12 seconds, the dolphin was back in the water. And again, I'm going to use that to my advantage. So how am I going to do that? Well, now I have an x and a y that I can plug in that I know is true for my equation. So I'm going to plug those in. All right, so right now I have 0 equals 12 minus 3. Well, 12 minus 3 gives me 9. 9 squared is going to be 81. All right, so if I want a by itself now, well, what can I do? Well, I can subtract that 7 over, and I can divide by that 81. So it's not exactly the nicest number, but it'll get the job done. We found what our vertical stretch is with a x-axis reflection as well. But knowing that that a is negative 7/81, now I can actually write what the function is. So y is negative 7/81 x minus 3 squared plus 7. So that is the function that models that dolphin's height while it's out of the water. All right. So, again, lots of good stuff. And hopefully you enjoyed today because basically it teaches us how to do all of this without that graphing piece. Okay? So what I want you to do is, again, there's a lot of vocab, a lot of little things to remember. So I want you to summarize what would a good way to remember all of this be? How are you going to remember this for your upcoming test? And then once you finish a summary, then just come back ready to do your practice work.